This exercise is a continuation of the last one on equations of a straight line. In this exercise, we're going to find information from a graph in order to turn it into an equation of the line that's pictured in the graph. One type of problem in the exercise is like the one you see here in text. Find the equation of a line with a gradient of 2/3 and y-intercept -5. These are quite easy if you're used to using the gradient-intercept form. So if we start with y equals mx plus c, then we can just simply take the information and substitute it for the right variables. So y stays as it is. M stands for the gradient, so that becomes 2/3. X stays as it is. And c is the y-intercept, so we substitute -5 for c. So adding a -5 is -5. That is the equation in gradient-intercept form. That's all you have to do. Now if you want the answer, or you're supposed to find the answer in general form, then we can move from there and convert it into general form by multiplying both sides by 3, just like before. Take the denominator of the fractional part and multiply by that denominator. Then we get 3y on the left-hand side. Dividing by 3 and multiplying by 3 cancel, so we get 2x. And -5 times 3 is -15. We're almost there. We have the 2x already positive on this side, so let's put that over on the left-hand side, just exactly as is, to start with the x part. And now I'm going to subtract 3y from both sides and add 15. So we'll subtract 3y and add 15 and get 2x minus 3y equals 15. So that's then the answer in general form, and the part in dark blue over here is the answer in gradient-intercept form. The second type of problem that you'll be asked to do is to take similar kinds of information from a graph. So we're always looking for a gradient and a point. Here the point we were given was the intercept. So this is actually the point 0, -5. So it becomes really easy to work with because you can just put it into the formula. But any other point will work too, it's just a little bit more work. So let's take a look at this example here. We have 2 points. We don't have a gradient, but from these 2 points we can figure out what the gradient is. Because we have the graph, we can actually just count it. If I read from left to right, I have a negative gradient. So I know that the gradient is going to be negative. I'm going down 2 and over 1, 2, 3, 4. So change in y is 2. It's already negative, so that's where the down gets turned into a negative. And I'm going over 4. So I get 2 over 4, or that simplifies to -1/2. Could have also found it from the gradient formula. So if you find it easier to plug in the numbers, y2 minus y1 over x2 minus x1, then I could have done that as well. I just have to be clear that this point is not a coordinate yet. I have to write in the coordinates. It's 5 in the x direction and 0 in the y direction. So those are the values I would use. And here we then get y2 is 0, y1 is 2, over x2 is 5, minus x1 is 1. And if I do that, I also get -2 over 4, and then that simplifies to -1/2. So both ways I get -1/2, whether I use the graph or the gradient formula. So far I know that the gradient is equal to -1/2. Now I need a point. I can pick either point, but let's pick this one because it's got a 0 in it, so it's going to be a little bit easier to work with. So I get -1/2 using the gradient formula equals y. Remember, my y2 switches to a y, and I'm going to use one of the points. In this case, the y coordinate is 0. And on the bottom I get x minus 5. That just simplifies to y. So when I do the cross multiplying, when I multiply these across to get rid of the fractions. Then I get 2y on one side, and on the other side, let's take negative with the numerator as usual. Negative 1 times x minus 5. And I get 2y equals negative x plus 5. Now I have to ask whether I want it in general form or gradient intercept form. I'll do it in general form first. My x is negative, so I'm going to switch it onto the other side, so add x to both sides and put the x first. So x plus 2y equals 5. And now it's in general form with the a here a 1, the b term is a 2, and the c term is a 5. So that's general form. And if I go this way into gradient intercept form, then I would divide everything by 2. So I get y equals negative x divided by 2 is negative x over 2, or negative 1/2 x plus 5 over 2. And that's in gradient intercept form. And the advantage there is I see the gradient. There's the gradient. And 5 over 2, or 5 over 2 is the same as 2.5. So that's equal to 2.5. And if I look at the graph, I can see that the intercept here is 1, 2, 2.5. So then I can read off and know that that's correct because I can see that the y-intercept on the graph is 2.5. Okay, there are variations of problems. Sometimes you get the gradient from the parallel line or the perpendicular line and things like that, but this is the basic concept for the entire section. You have to find a point, you have to find the gradient, and then you can put it into either form, general form or gradient intercept form. Okay, you're ready to get started.